Happy Diwali for Indians who celebrate it, who are in the audience. Unfortunate that this day got chosen for this talk. When I agreed to the talk on this day, I didn't realize today will be Diwali. So anyway, so this is the Festival of Lights for those of you who don't know what I'm talking about. Okay, so this presentation was originally given, as it says there, as a keynote at the IEEE ICDCS conference, and also more recently for 90 minutes at the VLDB conference as a tutorial. By the way, this is the first time I'm actually giving a talk at the local chapter of an area where I've lived for 36 years. Even though I've given talks in ACM chapters elsewhere, I haven't done it here. In the same way, a few months ago, I did the IEEE local chapter for the first time, even though I've given IEEE Computer Society chapter talks elsewhere. So thanks for hosting me. And I was trying to guess how many people actually show up. It's a pretty small percentage compared to the 475 who signed up. So we were trying to guess what percentage of the people will show up. I don't think it's even half the crowd. Yeah. Okay. The important URL is at the bottom. If you go there, you'll find all sorts of interesting information. And even in the future, as I revise the presentation, you'll see the slide decks, as well as whenever they make recordings of the talks, they will show up over there. So that's a place to go to also look at references to papers and such that I will refer to, as well as ones that I won't refer to, but they are interesting ones to look at. What else do I want to tell you? That's about it for the time being. So let's go on. So this is the schedule of the presentation that I had, outline of the presentation that I gave in Munich a few weeks ago at the International Conference on Very Large Databases. As I've been told, and we wasted some time, I probably won't get as much time as I got over there to go through this presentation, so I'll skip over some of the material. But the idea behind this whole presentation that I've been doing since April, when I started out in Hong Kong with my first ever presentation on blockchain, has been to, if you like, bring the mainstream database people as well as distributed systems people into paying attention to the blockchain space and try to take it beyond all this cryptocurrency craziness that many people are focused on, which I'm not focused on. I couldn't care less about cryptocurrency and open blockchains. I'm only interested in private blockchains or permissioned blockchains. And I think that's where the real major change is going to come. I don't care for all this, speculative stuff that's going on with this money business and going up and down and all that. I'm not bothered about any of that. I'm going to discuss in a very general way the whole story with permission blockchains and then get into some of the specifics. So the talk is intended for people without any background in blockchain to also get something out of it, even if they are non-technical people. But I also wanted to address some of the technical issues for the benefit of the geeks in the crowd. And by the way, my own background, which wouldn't have been obvious from what was said, all my 36 years at IBM, end of the year it'll be 36, I've never been a manager. So I've been a techie my whole life. And my lab is where relational and SQL came from. So we have a strong history in the database area. And of course, that initial work happened even before I joined IBM. So I joined what was called the R-Star project, which was the distributed database version of the original System R relational implementation. That was the first serious implementation of relational in IBM. And Ted Cord used to be in my lab when I joined 36 years ago. He is the father of the relational model. And SQL came out of the lab also. So, okay, let's go on. Blockchain, of course, came into existence with the fictitious person writing a paper on Bitcoin. And it's the underlying infrastructure for Bitcoin, Bitcoin being a cryptocurrency. And this was this guy, Satoshi Nakamoto. Nobody knows whether it's a man or a woman and whether the person is really Japanese or not, because it was a pen name that was used by this person to write the paper. Right now, of course, any number of organizations are very excited about this whole space. from little companies to big companies to governments to non-governmental entities like NGOs and so on, financial institutions, as well as all sorts of other non-financial institutions. By no means is this area, I mean, the application of blockchain restricted to only financial industry. There are all sorts of people working on different aspects of blockchains, from coming up with benchmarks to verifying the translation of a paper-based way of doing contracts to more formal mechanisms to then actually executing code, so-called smart contracts. There have been already commercial deployments in production sense of blockchain technology in the private blockchain domain. In particular, in February 2017, was the first commercial deployment where in the Guernsey Island, which is off the British coast, this Northern Trust, which is a Chicago-based company, developed software that's being used to manage private equity funds. So the value of the deals is high, but the volume is not high. So the amount of money dealt with by the transactions is very high, but the volume is not like your New York Stock Exchange or NASDAQ kind of volumes. And that's an important thing to keep in mind because the transaction rates that can be supported at this point are not very high. Sorry? Not true. We will have the discussions later. We are talking about very specific things at this point. And we are not talking about cryptocurrencies. We are talking about very specific private kind of blockchain deployments. In terms of ready for prime time kind of usage, the Hyperledger Fabric version 1.0 was released in July. Until then, it wasn't really considered ready for prime time. We have had versions like 0.5 and 0.6. And also, IBM provided on the cloud blockchain as a service. It used to be called the High Security Business Network, HSBN. It's now relabeled as the IBM Blockchain Platform. And that runs on the super duper mainframe with very high security, with guaranteed non-tampering of not just the data, but also the code. This is much more superior compared to Intel's SGX, for example, if any of you have heard of the secure execution enclave that Intel talks about. And we will get back to that one because Intel has got a project under the Hyperledger umbrella called Sawtooth, where they are trying to use it for blockchain. And they had said as of a few months ago that it was not yet ready for deployment. So it's still an incubation project. It's not yet graduated to what's called active in the case of the blockchain, the Hyperledger Consortium, which is a different terminology compared to Apache project going from incubation to top level. Here they're called active. In terms of the guys up the peninsula, they announced on October 2nd, Oracle, a blockchain cloud service. Right now, it's a lot of words. We still don't know the details of what the heck this is going to be. I've been desperately trying to find the details. I can't find anything other than the fact that it will be based on version 1 of the Hyperledger Fabric, which the consortium, they joined only in August, and now they have announced in October blockchain as a service on their cloud. There's an outfit called Grandview Research. They have come up with this estimate of the market size being expected to be 7.74 billion. Doesn't matter, what the exact number is. It's the order of magnitude with all these kinds of estimates that's more important to think about by 2024. And I already mentioned that I'm only interested in these private permission blockchain systems. Just to give you a bit of background, both in the distributed system space as well as database space, there have been lots of technologies that have come up or ways of doing various things that have been proposed over the last 3.5 decades of my own professional life. From the time I started at IBM, when we had a project on Byzantine agreement protocols and clock synchronization, which was being worked on by my colleagues. And while I was doing the presumed abort, presumed commit protocol that was referred to in the bio, we actually combined those two things and wrote a paper in, believe it or not, August 1983, worrying about Byzantine faults in combination with the more traditional kinds of faults that computer scientists have always worried about, which had to do with machines failing or disk drives failing or links failing. Add to that the intentional messing up of things by humans or machines that are more insidious and so on. To all sorts of distributed systems algorithms that have been proposed by people like Leslie Lamport, which had to do with how to even take distributed checkpoints when you have message passing ways of doing distributed computations, to PubSub. I've had my hand with MQ series, which is IBM's first transactional queuing asynchronous messaging system, which then got expanded to from normal kinds of messages to PubSub kind of messaging to distributed event systems and so on and so on. And then of course came RPCs and transactional RPCs, then client server, World Wide Web, and caching in a web context, to one thing that's very closely related to what we are going to talk about, which is workflow management systems or business process systems, which have to do with multiple steps in a long-winded computation where multiple entities may be involved. There may be parallel things happening, and then they come together and things like that. And then, of course, the cloud came in, and then notions of public cloud, private cloud, and hybrid cloud, and all that. In the database area, a little before I joined IBM is when the relational revolution started. And after that, of course, even as part of that, there had been a lot of work on different degrees of isolation and different notions of consistency. Don't for a minute think that all these relaxed notions of consistency came about only due to NoSQL. 40 years ago, they had already been talked about. The original paper on serializability already had relaxed notions of consistency. And IBM products and other guys' products have supported this in their databases for a long, long time, even doing dirty reads and things like that. Even relaxed notion of transaction commit, where you don't force the commit record to disk right when the transaction is committing, and having loosey-goosey things that are going on today in MongoDB and such systems. They have been there as options before, not as the only thing, unlike in the modern day NoSQL systems, which all have very flaky transaction semantics and not even necessarily single statement transactions. Then of course came all these notions of different kinds of replication, including what used to be called update anywhere replication, which has to do with what has become now popularly known as eventual consistency and things like that. Those things have been around for quite a long time, long before the Web 2.0 guys came into the picture. And then of course object-oriented databases, XML, and more recently JSON, the difference between OLTP versus OLAP, data warehousing and things of that nature, to now of course with the Web 2.0 guys coming in and finding all sorts of problems with the relational model in terms of the schemas being very constraining. All these very schema-less or semi-structured kind of databases have become more popular. Also the sharding, which is not anything really brand new. It's more like, we used to call it partition tables. Sharding just says that you can now have a lot more shards than the number of partitions that traditional relational databases supported. And of course, performance requirements have changed dramatically from the time we had TPC, where sub-second response time was considered a big deal, to now tens of milliseconds have become more the norm in the Web 2.0 kind of arena. And so that has caused lots of things to be done, like exploiting main memory and things like that. So, and of course, then MapReduce came, and Hadoop as a open source implementation. And of course, with the cloud, all the issues with respect to data privacy and the kinds of problems that you can encounter when willy-nilly people can hack into your cloud-based way of doing business rather than behind the firewall kind of thing also has introduced many additional security concerns and ways in which you had to deal with them and so on, new inventions along those lines. Plus, of course, lots of data privacy issues have become important, especially in Europe with trans-border data flow considerations having a role to play in how many data centers you have, where all they are located and things like that. The whole US-centric way of doing things that many companies got away with for a long time was no longer sustainable once you took into account the need for data having to remain within the borders of different countries and such. So the security and all that, as you will see, is a major part of the blockchain way of doing business. Okay, so what kind of problems are we trying to solve? So if you look at this picture, you find that when one company is shipping something to another company or customers in some other place, there are all sorts of entities that get involved. And so this picture shows airlines and banks and shipping companies and forwarding agents and customs and all sorts of people. And they all, of course, are likely to be using computers and having their own databases and so on, but there's no central place from which you can get to see everything there is to know about what all is going on. There's no single source of truth. And this results in a lot of inefficiency, more expenses involved, and it takes longer for certain things to get done, and also a lot of cheating and such things that go on. People post facto go modify documents to try to claim that it wasn't they who caused the problem, but it was somebody else who caused the problem. So a lot of forging and all that happens, especially if some disease starts occurring because something got spoiled during the transportation. People try to shift the blame to somebody else and things like that. So this whole way of doing things also doesn't have as much transparency. So the blockchain way of doing business says instead of each party having its own way of managing the data that relates to whatever is the transaction that's being performed, that involves multiple organizations, you are now going to do it in a way where there is a method to the madness with respect to how data gets modified. There is a single database which is replicated, which everybody has a copy of. By everybody, I don't mean any Tom, Dick, and Harry across the globe, which is the sort of thing that the open blockchain lets people get away with or promotes, if you like. Whereas here, you have to be admitted to the party before you are eligible to see anything at all. As part of admission to the party, you have to reveal the identity of yourself and such. So there's a lot more known about who the characters are that are being dealt with. That's not to say that everybody believes everybody to be straightforward and all that. There are still going to be checks and balances, but the important thing is it's not like you don't know who is the party that's doing something. You very well know because they have their identity and they have to be authenticated, they have to be permitted to do certain things and so on. So, in that sense, the idea is that just like in a bank ledger, any changes that are being performed will be recorded in a way where there is a complete record of all the things that happened, who did what, when, and such. Even if there was a mistake made to begin with, the correction will not be done in place, but instead it will be a new entry in the ledger saying this is a correction for the problem that was created originally. So in that sense, the immutability property will be there. This is not to say that the database is not going to do in-place update. You can still do in-place update, but the record of the changes that's being kept, the log, that's the blockchain really, which is like a traditional database recovery log where we don't go do in-place update. We keep writing new log records, which is like an append-only file. The same sort of thing happens here, except that what we record in the blockchain will be a lot more than what we normally used to record in a recovery log, which is purely for the purpose of dealing with the sorts of problems that I mentioned, excluding the Byzantine problem. It's a failure of the machine, power goes off, and the main memory contents get lost, or the disk drive even craps out, and then you have to deal with that one, or links fail, and so across vast distances, you need to do distributed transactions and guarantee atomicity and things like that. And also the way in which the different steps are taken in evolving the state is done in a way where the different parties that are involved agreed to do it. And the fact that they agreed is recorded in a way that they can't later on claim that they didn't agree to. So there's a lot of this kind of putting people to agree, and then with their signature and all that being recorded in a way, in a replicated way, so that even if their machine blows up or multiple machines blow up, you still have a record of what all transpired, is an important aspect of this. And we'll get into how, the sorts of things that are shown here, digitally signed encrypted transactions and ledger, is all going to be accomplished. So there's a lot more details. I'm not going to talk through every slide. I'll let you guys later on look through the slides and read the extra levels of information and such. This also is expected to, this way of doing business is expected to improve efficiency, lower the cost, increase transparency and so on. And also auditing and all that will be a lot easier because the auditor doesn't have to go look through umpteen different databases and understand the differences between the databases and so on. So any kind of heterogeneity that the different parties might have had because they use different databases and such, and also programming in different languages and all this kind of stuff that you would have had to deal with if you wanted to do auditing across the old way of doing business, is all made much simpler in this modern way of doing business. So what is a scenario that will give you a little more of the technical details? So this is what we call a peer node. It's one of the nodes in that network that you saw before. And you have a blockchain developer who develops the client-side application, which is the one that's going to interact with users and so on, as well as what's called the smart contract, which runs on the server side. You can think of that like a stored procedure if you're a database person. And of course, this contract is not developed by just one person, as this picture might be miscommunicating. It's actually developed jointly by the different parties that are part of that contract, okay? And what does that contract do? It does database interactions, puts and gets and deletes. I've shown it that way because at this point, at least in the Hyperledger fabric, it's supporting one of these NoSQL kinds of ways of doing business, right? It's not supporting at this point a relational model as it comes out. You can go plug in if you want a relational model, but still the API that the pluggable interface provides is a very NoSQL-ish kind of API. So my current project is to actually change that whole picture, but I'm not going to talk about the details of what I'm doing. Maybe another talk I can give some other time. But as this contract executes, it's like an application program, right? It's making database calls, reads as well as writes. And those will affect the database. But on top of it, whatever this transaction does, in a different way from a traditional recovery log will get recorded. The items it read, the items it modified, and things like that. So in that sense, it's even recording what items are being read. We'll get into more details later on. Also, as the smart contract executes, it might invoke other smart contracts, and events are emitted. This is why the distributed event reference was made by me earlier. People can subscribe to these events. The events could be the invocation of a contract or addition of a transaction to the blockchain or some other sorts of things. So in addition to the database, the blockchain is there. At least in the Hyperledger fabric way of doing business, the database is really a redundant piece of information. You can blow it away and you can still reconstruct the database state by rummaging through that blockchain. There are other guys who are doing things differently that I'll refer to where you cannot do that because they don't put everything in the blockchain, okay? What else do I want to tell you? We also call, in the fabric way of doing business, the smart contract as chain code. Don't ask me how that came about because I've been poking my nose into this Hyperledger fabric only for the last year. And the project has been around for 2 years now, so I'm not party to all the decisions that were made. The word blockchain is there because this data structure that you see here consists of a bunch of blocks pages which are linked together, and each block contains a certain number of transactions. There's nothing fixed about what the block size should be and how many transactions are there and things like that, because the size of the transaction also could vary dramatically from small number of items being read and modified to huge number of items being read and modified. So the notion of smart contract was a generalization of the Bitcoin initial idea from managing just a single item, namely the Bitcoin, to managing any kind of asset, be it digital or physical asset, the digital representation of a physical asset, digital asset being recordings and such, right? Whereas physical things could be diamonds and so on. But you are representing the diamond's ownership and such, weight, whatever, various characteristics in digital form. But there is still the physical thing also, and now you need to make sure that you are able to match the two so that if somebody tries to cheat you by substituting a fake diamond for the real one, you should be able to detect it, and there are things that can be done to do that. So the notion of smart contract was something that was invented by the Ethereum guys who did the generalization from Bitcoin. We'll get back to some of that. So there's all this history kind of infographics. I'll let you look at it at your leisure. The important thing to point out is that we are at this stage of crossing the chasm between last year and this year, when all sorts of important developments are happening, and it's expected in the next couple of years there'll be some losers in this whole race to gain dominance. It's important to realize that it's fairly chaotic at this point in the sense that there are no standards. The only good thing compared to the chaos in the NoSQL world is, in the NoSQL world, each guy has its own way of doing business. So the number of players is a lot more, and I have my friend here, one of the NoSQL guys. But at least in the case of the blockchain world, it's consortia that are working together. I mean, members are working together in the context of a consortia, and there aren't as many consortia as there are NoSQL guys. So that's the good thing here. But there is still no standard across different consortia's ways of doing business. So the hope is that as things evolved and you went from dealing with only cryptocurrency and such things, which have been misused by lots of people for doing shady things, drugs and all sorts of things, to now more industrial or commercial or real world kind of things, rather than this, in my opinion, a lot of wishful thinking that some people think the whole world's problems will be solved if everybody switches to a cryptocurrency. This is like those people who thought there'll be only one language. Esperanto will take over the whole world and there'll be happiness and all that. This is not going to happen. So there are many of these youngsters especially who think all the world's ills can be solved if only one currency takes over the world and the fiat currencies will all disappear. I don't think it will happen in my lifetime at least. So forget those guys. So it was actually a favorite place, and it's still a favorite place for a lot of cryptographers and theoretically oriented people to crank out gazillion ideas and algorithms. And also, of course, the VCs are funding all sorts of companies, as you'll see soon, which are all in that space that I'm not really interested in. But in terms of real-world applications that are going to make a big difference, as the father and son team that wrote the book at the bottom says, they feel blockchain technology is the second coming of the internet. They think it's going to have a dramatic impact on all aspects of society. And I heard the father actually give the talk for an hour. And he said, yeah, I'm hyping it a bit, but believe me. And then he rattled off a whole bunch of these use case scenarios. And even I myself in the last year have heard enough inside IBM about the various projects that are going on, which are in partnership most of the time with people outside IBM. I'm more and more convinced that it is going to make a big difference. So here is a long list of areas, vertical domains, where blockchain applications are being developed. Most of them are still in the kicking the tires kind of stage, prototyping and so on, but some are in production usage, as I will point out soon. So the green names are the names of organizations that are actually involved. And if you go to that page that I referred to at the beginning, you'll find a New York Times article reference, which had a great number of use case scenarios that they describe. that even the layman can understand. So things like, for example, Walmart. IBM has been working in the food safety arena in China, farm to fork, that kind of thing, with Walmart. Maersk is the world's largest shipping company. It's a Danish company, and they are obviously into shipping things from country to country and such. So in the logistics space, even FDA has been working on health data exchange, where of course, as I mentioned before, the privacy and all that is a big deal, HIPAA regulations and such. And then trade finance, IBM is using it even for IBM Global Finance, where people buying machines from IBM will get financing, and it's been expanded to do other things too. And then there is DTCC, we'll see a reference to it a bit later. And I already referred to that Guernsey Island application, which is the private equity fund management by Unigestion. I referred to diamonds. This is a big thing that's going on right now. 1.2 million diamonds are on the Hyperledger fabric in production usage. They can even deal with things like blood diamonds and forgery along the way. You can do something like a fingerprint of the inside of the diamond, and it turns out different diamond pieces have different fingerprints, quote unquote, and that can be recorded in the blockchain. And later, if somebody does a substitution, and then you take the X-ray of or fingerprint of that thing that is claimed to be the real thing, then you will see that it doesn't match up with what's in the blockchain. So that's the way in which things like that can be dealt with. And so provenance, where all this thing has gone, you can track all that in a way where it's irrefutable because people's signatures are there and things like that. And so low volume stock trading, Japanese exchange is also working on something for that kind of environment, not for your high volume transactions. And even in the Bay Area, I had been at a meetup where there was a panel on blockchain, and one of the speakers was an American but working in Africa on helping unbanked population do payments to each other and all that using blockchain. So there are many, many such application areas. And this is just giving you some of the logos of the different entities involved just to make it look nicer and all that. There is this blockchain for every industry. The idea is to say, don't just think this is only for the financial industry. In fact, all the ones listed here are non-financial industry kinds of applications, insurance, travel and hospitality, even education, for example. And many governments are competing with one another in the Middle East. In UAE, Dubai and Abu Dhabi are competing with each other with respect to who's going to exploit blockchain, how soon, for what all things. And so Dubai has decided that by 2020, they want to eliminate all paper for government-related stuff. So they are assigning national IDs to all the Emirati citizens. And once you have the biometrics to prove who you are, all the things that you are eligible for, discounts, free thing, whatever, is all going to be on the blockchain. And you just walk into any institution which provides some service, they'll know immediately what all things you can get at what price and things like that. So, and they are doing it in various areas of the country, meaning Dubai Customs, Dubai Trade, and entities like that, and IBM as well as Consensus and other companies are involved. Some of the banks are also involved in doing all this. In terms of evolution, this is from American Banker. Bitcoin was initially thought of as being for drugs and such. I'm not saying this, they are saying this. Between last year and this year, there's been a dramatic shift in the optimism level with respect to how soon this is going to become real in terms of production deployments. Last year, people thought it seems it's a decade out, whereas this year already, and this came out, by the way, in March. At that time itself, there was even more optimism than what it was last year. And like I said, there are many consortia, and like it happens with some of these things, some people don't want to bet on just one consortium, so they are members of multiple of these. So for example, JP Morgan is in the Enterprise Ethereum Alliance as well as in the Hyperledger. So they are hedging their bets just in case they ride one horse and it fails, they are not left holding the bag. So at least as of February, Hyperledger had the largest number of members, whatever that means. It doesn't really mean anything if there are itsy-bitsy players, two-man operations that are members. But interesting thing is, as you will see a bit later, there are some really major players that are part of Hyperledger, and more recently, of course, the new kid on the block is the Enterprise Ethereum Alliance, which is trying to take Ethereum to the private blockchain domain from the open blockchain. Okay? There are all these sorts of things going on. I won't dwell on this, except to point out there are 4 production deployments already. IBM Global Finance, Northern Trust, Everledger I talked about. SecureKey is a startup in Canada which is helping a bunch of banks do know your customer kind of applications using blockchain. So what else do I want to tell you? So there is this DTCC, which is big time into evaluating blockchains. IBM is one of the players along with R3 and Exoni. And they are expected to go live sometime early next year. What the Enterprise Ethereum Alliance guys did when they announced it in February was to take something that JP Morgan had developed and had been using in-house as a private thing. They chose to, called Quorum, they chose to open source it, and that forms the basis for doing the private blockchain for Enterprise Ethereum Alliance. I've already talked about some of these other things. So unlike many of the other approaches where people started out thinking big in terms of what a blockchain should do, and then as an afterthought, they used a database system to store the state. There is a startup in Berlin, BigchainDB. They are trying to go the other way, start from the database end and try to think about what are all the features that relate to blockchains that they would like to get out of that database. It's not as exciting as it might sound because they haven't started out with anything very, industrial strength and all that. They started out with Rethink DB, just one cluster, which didn't have all the high availability. They didn't even bother to make sure that the DBA doesn't go and drop table and things like that. Even the most mundane of things that could go wrong, they are not worried about, so they got beaten up in their blog. What are you guys talking about? Why should anybody take you seriously if you don't even realize that in this immutable blah, blah, blah kind of story that you dish out, you are not even protecting the database from having a drop table being done and wiping out all the content. And they were not even logging the contents of the database and of the table when they were doing the drop table. So it's not even recoverable in that sense unless you had a backup and so on. More recently, they've started mucking around with MongoDB. So MongoDB put out a white paper. It's still not clear exactly what the long-term story with all this is. Lots of startups and activities. I won't get into the details, but this is a CB Insights one. This, of course, includes cryptocurrency and such. It's not just private blockchains, okay? All over the globe, this picture doesn't even include US companies. It only includes non-US companies. But almost every continent, there are companies working in this overall blockchain space, including open blockchain. Even in Africa and India and Southeast Asia and places like that. And South America too. But somebody was bothered that there is no company in Brazil being shown here. I don't know if anybody is Brazilian here. Somebody got upset that their country was not represented. It's not my making, it's the CB Insights guys who produced this. I actually checked to see today whether there's an updated version. I couldn't find one. This is all like February, March kind of time frame produced graphics. So there's a paper in this year's ACM SIGMOD conference. That's the premier database conference of ACM. This is by a group of people in the National University of Singapore, working in conjunction with some people in mainland China. This is the first effort in coming up with a benchmarking framework for private blockchains. And as part of that, they have this general model that I liked, but I'll refer to this work a bit later in greater detail. So the blockchain itself, as it's shown here, is a collection of blocks that are linked together, and even the links are being maintained in a way where if somebody drops one of the blocks or adds a fictitious block, it can be detected because there are hashes that are used to connect the blocks together. And so the hash will not match if you monkey around with the link itself and introduce something new or modify what's existing. And then you have the execution environment for the smart contract itself. There are many containers and virtual machines that have been defined. Even languages have been defined specifically to write the contract in. So this is a place where even programming language kind of people and operating systems kind of people have roles to play, because there's a lot of attempts to make the whole thing be deterministic rather than looking at the position of the moon and looking at the time and things like that, because different nodes, when they are in parallel trying to do the same thing, if they do any of those sorts of activities, the results could be different. And they want to guarantee that there is determinism in the way these things are done. So they prevent you from doing all sorts of normal things that you might do in an application program, like current time kind of access in a SQL register kind of way and things like that. And then, of course, the database side, there are variations with respect to what sort of database systems are used and what kind of data model is being used to model the entities that are being manipulated, which are these assets, as I talked about, digital or physical assets. So if you look at things that way, the architecture has many points where you can make different choices. And that's the trick with all this. At this stage, things are still very much fluid. People say, this is what I did. They don't necessarily rationalize why they chose to do things in a certain way. And so if you look at these different systems that are around, that are still undergoing significant development, you will find all sorts of differences, but there is no method to the madness with respect to why one group of people chose one way of doing something versus another group. And that choice has to do with using a relational system versus a non-relational system, to dealing with only non-Byzantine faults or regular faults as well as Byzantine faults, to this permissionless versus that at least is a more clear-cut big deal distinction, open blockchain versus private blockchain. And then whether the state database contains only the latest state of the data that's being managed, or you have the past versions of the data also. Those of you that are into databases will know that that will let you then do time walk and temporal SQL queries and so on. If you have the past versions of the data, that will be important for doing things like auditing, what state changes were done by whom and so on. We can still do that by crawling through the blockchain, but it's not readily available in the database if the database is only keeping the latest state of the different pieces of data that are being manipulated. And then the other major one that you'll keep hearing about a lot is, do you keep all the data in the blockchain and hence in the state database, or do you keep the data actually in some other external store and keep only the hash of that data in the blockchain? Some people are promoting this off-chain data management because they're saying, oh, if I put something in the blockchain, it's there forever, and I don't want to put some sensitive things there because there's no way to redact it from there. And also, depending on what database system you're using, it might or might not deal very well with vast amounts of data being there. As you will see, this data is getting replicated a lot, not just in the nodes themselves, but also between the state database and the blockchain. And also, depending on how you are doing recovery, or when a new node comes into the picture, how it gets initialized with the data, it might have to rummage through the blockchain from time 0 until current time, which is going to be a long time once these things get into production usage. And then you have to deal with the massive amounts of data that would be stored over there. But at the same time, I have to point out, in many ways, sticking the data somewhere else and using only the hashes and managing it through the blockchain is sort of like you are going backwards on why all this blockchain thing was considered a big deal. Because now you've suddenly gone into this mode where many of these guys just have one copy of that external store. So much for all this autonomy, this, that, and tolerating gazillion failures and so on. Even if you replicate that thing a bit, that's still not the same as the amount of replication that the blockchain itself is providing and accommodating more kinds of weirdo failures and combination of failures and things like that. So in some ways, that's not very satisfying. And also for those of us who know about failures, all the two-phase commit kind of stuff that you have to do between keeping that information, the off-chain and the on-chain thing in sync, and exactly in what order you do these updates and all that. A lot of these people wave their hands when they discuss this off-chain way of managing the data. Okay, so having talked a bit about databases, many of you will know about different ways in which replication is done in databases for different purposes. So the first bullet is talking about how, in the context of disaster recovery, we use the log from the primary node and apply that log on the remote data center where the replica is kept. And that assumes that the database systems are the same, the page size and all that are the same. So you can pretend like you are in a restart recovery mode on the primary itself when you are actually applying those log records on the backup. So this is the most straightforward thing to do, but it has the restriction that it has to be a complete replica and everything has to be the same version of software, blah, blah, blah. The second one is the one where you can have more flexibility. You could replicate between, let's say, DB2 on the mainframe and Oracle. Because what we do is we take the logged information on the primary, but we don't use it as is. From that, we generate SQL statements, and then we redo those SQL statements on the backup node or the copy node, replica node. And by doing this, you can even subset the information, the schema can look different and so on, as long as the mapping is predictable kind of mapping. And that's what IBM's Q replication does. And it has many other things in it in order to make sure that you don't serialize the redoing of those transactions on the replica, because on the primary, you are dealing with transactions in parallel. And if you now serialize the application of those SQL calls in a single transaction at a time, then the backup might not be able to keep up with the primary. So there's all this fancy stuff that's done to identify which things have to be done serially and which can be done in parallel by doing a dependency graph analysis. And that's the way to ensure that you get much better throughput and the backup is not too far behind the primary. The third one that Mike Stonebreaker, my buddy who got the Turing Award a couple of years ago, keeps promoting as if it's a panacea for all the world's ills, is this idea that instead of looking at the log and creating SQL statements, he says grab the SQL statements as the primary application issues the SQL statements, and then just replicate them. While it sounds like it should work, there are all sorts of issues with, for instance, any kind of non-deterministic things that might be there, like looking at timestamp and things like that. Because invoking even a ran function in that original SQL statement, because then the results can be different between the primary and the backup. And also, at least the way it's done in this system called HStore, the commercial version of his VoltDB, they essentially serialize the execution of transactions both on the primary and on the backup, which is not good if you're going to have high throughput transactions, as well as there are other issues with things that he doesn't talk about, which has to do with long-running transactions and short transactions getting intermixed and things like that, high priority, low priority, all sorts of issues. If you're interested, we can talk offline about all this. But in general, you'll see, as I describe later, how the blockchain does its thing. There is a lot of serialization of transaction execution. For those of us who have spent our lifetime working on high concurrency in database systems, my claim to fame in a big way is record level locking with write-ahead logging, which is some of the list of systems that was shown in the bio. Even non-IBM systems. SQL Server, by the way, is not IBM. She tried to say all those systems were IBM systems. Sybase and even Informix did it before we bought them. You will see that there is, at this point, and that's why my reference earlier, which my friend here was trying to deny, that transaction rates at this time in the blockchain world are pretty pathetic compared to the millions of transactions per second that we all get excited about in the TPC benchmark kind of scenarios. Okay, so what is this benchmark thing that I referred to earlier, that Sigmod paper by the National University of Singapore? So they've come up with, and this paper will get cited like crazy because the first serious paper to be written on benchmarking for private blockchain systems. This is, in case some of you know, Bengchen Hui and Qian Li Tan. These are the professors at nonUS. So they've defined various kinds of benchmarks that are similar in flavor to TPC benchmarks, in the sense that there is the OLTP style benchmark, and there's the OLAP style benchmark, because you can do analytics on the blockchain data, as well as things that are intended to exercise different or stress different parts of the system, which have to do with things like the execution engine, the data model, the consensus layer, and so on. Okay, so this is a good piece of work, and they have now expanded the original paper that was published in SIGMOD into a survey paper. I have a reference to that, and you can get access to that paper, even though it's still not finalized. What they did in this piece of work was to compare Ethereum, Parity, and Hyperledger Fabric, but it was the previous version of the Fabric, meaning the 0.6 release, not the 1.0 release, that I'll talk about in greater detail really soon. But they've done all this in a way where they've made it easier to plug in yet another blockchain system and try to evaluate its performance. Their conclusion, at least based on what was done before, was that Hyperledger Fabric is pretty scalable, except that it doesn't scale beyond 16 nodes. Okay? But otherwise, it was quite a bit better than the other guys with respect to many of the other kinds of measurements that they have made. But there is a significant difference between 0.6 release of the Fabric and 1.0 that I'll refer to, which has to do with the PBFT algorithm that was used for consensus in 0.6, which does deal with Byzantine faults, but it's pretty expensive. Whereas in 1.0, we don't deal with Byzantine faults. So Kafka is being used as the consensus mechanism, and so it's much more efficient. But they are supposed to be re-evaluating the benchmark using 1.0 of Fabric also, while they are expanding the set of systems that they are evaluating too. So I've already talked a fair bit about Ethereum. It still has all the major problems of Bitcoin, in the sense that it has this notion of proof of work, where this is, in my opinion, it's a royal waste of energy and power and everything in this day and age of green consciousness and everything, where all they are doing is cooking up this whole math problem to be solved, and then whoever solves it thinks he is a winner to add a block of transactions, but it's not guaranteed that there's only one winner. And so you have all these goofy things like the blockchain can fork because multiple people are adding blocks in parallel. So it's like a versioned software, right, where you are branching of versions, or even data if you had conflicting updates being done in parallel and you create two different versions that were derived from the same original version. And so it results in the case of Bitcoin, 10 minutes for a transaction's outcome to be known. Even that is still a probabilistic statement, because they wait for whoever is showing up in the longer chain, which they assume will ultimately win out, to be the winner. But in order to even generate this, which is longer and doesn't sound good, but they are waiting for a while. And this results in 7 transactions per second. And because anyone across the globe can join the party without having to be admitted, this also means as time goes on, whenever new people come in, it takes even longer, because the scaling is getting messed up as more parties join. And also it takes longer for anyone that comes in to catch up, because they have to process from time 0 all the blocks. But they have this notion of gas, which they use to charge for this. So it still does the proof of work as the consensus mechanism, and it has its own machine language and virtual machine for coding your apps in. They have this notion of currency called Ether, but the more exciting development that started in February or so is the announcement of this Enterprise Ethereum Alliance, which is having lots of players, but the main ones being JP Morgan and Microsoft. Consensus is also part of it. So they took, as I said before, what JP Morgan had been using internally which JP Morgan chose to now open source, called Quorum, and that's the basis for providing private blockchain ideas. The consortium itself is working on other more mundane things like, compliance testing tools and benchmarking and things like that. So it's still work in progress, not ready for prime time, other than the fact that Quorum had been used internally by JP Morgan. That gives them some level of confidence and all that, that it's good stuff. There are more details here. I won't have the time to go through it in great detail, but let me just point out that they talk about the fact that there's a single blockchain architecture, all public and private smart contracts and state derived from a single common complete blockchain of transactions. So you will see soon when I talk about how version 1 of the Fabric works, we don't have this notion of public versus private and also a single blockchain across even all the different private ones. We have everything disjoint. That is, the blockchain is disjoint for one group of private people compared to a blockchain for the other group of private people, and the corresponding databases are also disjoint. If I show you the next slide, you will see what I mean by all this. So here, I can't be pointing at both places, sorry guys, I have to choose sides. There is a single blockchain, and then you have this notion of public state, which anybody can see, and all the details of the data in this is revealed in the blockchain. Whereas for the private one, they only have some high-level fluffy stuff in the blockchain, which is what makes it non-redundant information, because the real information is only in the private database. So I don't know how they're going to deal with the blowing up of this. Maybe they are relying on the fact that there are enough copies, and they are not going to treat this as redundant information compared to what's out there in the blockchain. So as you can imagine, these are the different nodes in this network. You have to be admitted to the party, but on top of it, you have to get admitted to the exclusive club of subsets of these people. So this is like a Venn diagram. You can have n number of people in the whole network, and then subsets of the n can form their own subgroups, or we call it channels. These guys are just calling it like private state. And so you can see that the green one is here, there, and there. The green state is not in the other nodes. But the same guy can be part of multiple channels. Let me use the same word for these guys, channels, right? So this guy, this regulator is in 4 channels, whereas this guy is only in 1 channel, the blue channel. Whereas this guy is in only 1 channel, that guy is in only 1 channel. But it so happens that the way they have chosen to display this picture, all the non-regulator and participant 1 are in only 1 channel, but the regulator and participant 1 are in 4 channels. So the same sort of ideas apply in our case, but the specifics of this business of having only 1 blockchain, but having separate private state and public state is different from what we have. So that brings me to the Hyperledger project, which is something that IBM initiated by contributing code, as it says in February 2016, went to the Linux Foundation and started this under the umbrella of the Linux Foundation. The name got changed and all that. You can read all that. Its big thing is supposed to be the fact that it's open source, open standards, and open governance. A lot of times when people say open source, there's only one company which really controls it, like MongoDB, for example, right? Whereas here the attempt was to make it really, truly open source, although as it happens with many of these things, there'll be one prime driver, but the steering committee and all that now has elections and such. The greatest thing that happened yesterday, I believe yesterday or today, is that Baidu decided to join. That's why I put it in red. For those of you who don't know, it's like a big deal Chinese company. It's got even more customers than Facebook and such, I believe, although I'm not 100% sure about that. But there's this Baidu, there is Alibaba, there is Tencent. Tencent being the equivalent of Facebook in some ways, because WeChat is part of, is a product of Tencent. Also, this is the one that I said Oracle joined in August, and then they announced in October. But like I said before, you'll find JP Morgan's name also here, yeah. Even though they are one of the major guys behind Enterprise Ethereum Alliance. So it's got many big deal players here. So the major difference, as I said, between 0.6 and 1.0 is that in 0.6, once you got admitted to the party, you got to see everything, all the transactions, all the data. This clearly was not considered a good thing. By the way, this is one of the major objections to even the original open blockchain idea that any joker anywhere in the world can go peep into this stuff and figure out all the things that are going on. To me, when I heard that first, I'm like, who would want this? Would, you know, Safeway and Walmart want each other's data to be visible to the big deal competitor in their domain? So even in this private blockchain world, the lesson we learned was that people are not happy just because they're in the same network that they should have access to everything. So that's why this notion of a channel was introduced to say that in addition to being part of the network, you have to be admitted to a subset of the parties which are choosing to have contracts amongst themselves and so on, to be admitted into that party before you can see anything relative to what's going on in that subgroup of peer nodes. So it also provides for, in addition to this confidentiality and so on being subset appropriately, it improves scaling, because if there are any serializations that are going on, it's not now going to be across all the nodes. There can be 100 nodes, but your own private grouping has only 4 nodes. So the serialization will be only within those 4 nodes, serial execution of transaction, whatever the thing is that we are bothered about. And then even the consensus and such can be now tailored to work within the confines of the subgroup. And even there, in the past, all the participants had to agree on which transaction should proceed forward and things like that. Whereas with the new approach, you can have different kinds of members. Some are called the endorsing members, and the others are called, the remaining guys are called non-endorsing members. So only the endorsing members, even there, only a subset of them at the choice of the submitter of a transaction need to get involved in arriving at a consensus. And then other guys are merely tracking the changes. They have the state database. So there are many projects under the Hyperledger umbrella, the Fabric being the one that has reached that active status, as I mentioned before. But there are these other projects like Iroha, Sawtooth, Composer, and most recently something called Quilt, which is the interledger protocol that Ripple came up with. That has been brought in as a project under the Hyperledger Consortium. So what are some of the elements of the architecture? I already introduced this notion of a chain code or smart contract. It's written in a language called Go. And there are 2 kinds of smart contracts. The more common one is the user-written chain code. But there are also the system chain codes, which are used to deploy the user chain codes. And this is like catalog versus user tables in a relational system, that kind of distinction, right? Or system utilities versus user level SQL statements, that kind of distinction. The assets are represented as key value pairs. They can be in binary, which is all that was supported until version 1. In version 1, the key value store level DB was enhanced by also letting you use as an alternative CouchDB, which is a document database which supports JSON. As I said before, the blockchain has the full state, including the past history and so on, whereas the state database has only the latest state. And then you have the notion of transaction, which is a blockchain transaction, which in the picture I was showing before, when the client invokes a transaction, invokes a chain code or the smart contract, it in turn can invoke others and so on. Ultimately, when control goes back to the client, that's the end of that blockchain transaction. And you should view that as the end of the corresponding database transaction also. But since level DB and all that don't have real traditional transaction notion, there's all sorts of hokey things that are being done to, in effect, give you that state of affairs without the DBMS, in fact, supporting multi-statement transactions, okay? And that's where a lot of serialization is happening, because the system itself doesn't support multi-statement transactions. So if you execute only one statement at a time and you do some other goofy things, you can give the pretense of multi-statement transactions. And I mentioned that in this release, 1.0. Byzantine faults are not being dealt with as it comes out of the box because it's using Kafka, which is a pub/sub way of distributing transactions. It's not using that PBFT algorithm, which is what Barbara Liskov and company came up with as a more practical one than what Leslie Lamport had come up with originally. And this was done, of course, to improve performance, but because it's a pluggable interface, both for the database and the consensus protocol, if you want, you can plug in PBFT also. But this is not currently being shipped. And as I said before, both the IBM blockchain platform, which is already available and it's all there, and the previous version was called HSBN, which was on the 0.6 release. The Oracle guys have said that sometime next year they'll make it available. They've made the announcement saying version 1 will be the basis for what they have announced as the blockchain cloud service, BCS they are calling it, which was done in their open world on October 2nd. So just to give you some more details for those of you who are somewhat geekish, this is the blockchain, which you can think of as an ever-growing sequential file. It doesn't have to be literally a single file, but it's multiple files, just like a traditional database log can be spread across multiple files. But conceptually, it's a single ever-growing file. And then you have the state database, which was previously this dumb key value store. Now it's a bit better thing that is an option, which is CouchDB, which for us, people who, not me personally, but my predecessor who gave birth to relational, for us to be putting out something that doesn't support relational seems counter to my tastes. But anyway, that's what's been done so far. It does provide with CouchDB a bit of range query and so on. That is part of the transactional way of doing business, which I'll get into in a minute. But you can do fancier queries, but those are not subject to some of the transaction things that I'll talk about. You can ask some really fancy queries that CouchDB supports on the JSON portions of the data, but that's not subject to some of the optimistic concurrency control stuff that I'll talk about in a minute. In addition to that state database, there are two other indexes that are there that are managed by using LevelDB. And those indexes provide you the ability to figure out, if you're interested in a particular piece of data and you want to know what are all the transactions that mucked around with that piece of data, this index will show you where in the blockchain are the different transactions that modified a particular piece of data. But it's not value-based indexing. So you cannot, from that index, figure out when was this location field having San Jose as the value as opposed to Yorktown Heights. That you can't find out. You have to laboriously go through all the modifications, because this is not like a B+3 kind of index. And the other one just says where are all the different transactions that executed. Given a transaction ID, it will tell you where it is in the blockchain file. So these are fairly mundane things for those of us who have dealt with all sorts of fancier things in terms of indexes. And then there is this reference architecture, which has various components I won't get into. Obviously, because of this membership notion that you have to be admitted to the party and all that, there are certificates and private key, public key, all sorts of encryption-related stuff that's part of this picture that makes it all, extremely comprehensive and provides for all sorts of role-based ways of doing things. There is more stuff being worked on in this space. How it relates to any other kind of things that you might have with your, I don't even remember what, X.509 or something. All sorts of other membership things that might be part of some other standards and things like that. And there are also rules with respect to, what it means for a transaction to be endorsed by different peers for it to proceed to actually completing and things like that. Okay, I'll not dwell on this because I just don't have the time. So now comes the most interesting thing. How does a transaction execute in the Hyperledger fabric in version 1? This is different from what used to happen before version 1. So there are 3 steps to a transaction execution. The first one is what's called simulation or endorsement, which is invoked by the client issuing an API call which says channel.send transaction proposal, okay? He gets to choose, we don't care on what basis, a subset of the endorsing peers to whom the transaction is being sent. This is like database design issue. This is left up to the designers of the application to figure out all this, the solution or whatever you want to call it. But the effect of that is the input parameter is sent to the invoked chain code, which then starts doing its thing, as I explained at the very beginning, where it makes all these database calls. It might also invoke other chain codes and so on. While it's doing its reads, the calls are sent to the database system. But whenever it does any kind of modification, delete, update, or insert, create, whatever the call is, those calls are trapped by the fabric layer that's sitting between the chain code and the database system. Because this is a simulation. It's not actually doing the database updates. Which means if you do a read of item 1, modify item 1, and again read item 1, guess what? You won't see the effect of your own modification. Because the modification didn't go into the database. It's being kept off to the side. This is like how they do private workspace thing in optimistic concurrency control schemes. But what that layer in between is doing is, the fabric layer, tracking what's being read, which version of the different piece of data is being read, and what are the changes that are being made as the chain code or multiple chain codes execute. At the end of it, it packages all that and sends it to the client. And it's receiving such things from however many endorsing peers it sent that transaction invocation to. Now, that client can compare these read and write sets it got and make sure that they all are in agreement, or it doesn't have to do it because it will be done anyway later on. But if you want to get an early out, you can do it right there, and if there is a mismatch, then you give up. Also, you can have things like, oh, Mohan is an important guy. He has to always bless every transaction. But amongst the remaining 5 people that got invoked, it's enough if a majority bless the transaction. There are various rules like that you can formulate. We don't again care. We give you the means to declare such things, but exactly what you choose to do is your problem. This is again like database design. We need red books that give guidance to customers on what to do and under what condition and so on. But at the end of that, if this client says, okay, I've got all the blessings and so on, and they're all matching their things, read set, write set, it ships that transaction by sending it to, in step 2, the channel.send transaction. The original thing was a proposal, right? It now sends this stuff to the ordering service, which, as I said before, is Kafka in this release. That ordering service receives many such transactions. It puts them all into a block pretty randomly. It's not doing anything very intelligent. It's not examining the read and write sets and does anything like, let me minimize the number of transaction aborts and so on, because we will soon see why transaction aborts come into the picture. So he then ships these blocks, this one block that he created at that point, to all the nodes, including the original guys. See, these guys, they'll never play the role of endorsement, the committing peers. They are merely tracking state changes. They don't even have the chain code installed in them. Whereas these endorsing peers have the chain code, but not all of them will necessarily be even involved in that first step. A subset of them could be chosen, and that's left up to the client as to which subset he chooses. But at the end of that simulation, they have amnesia. They don't have any more persistent tracking of anything that transpired before, because they didn't make any database changes, and the fabric itself doesn't have any other persistent store where it can stash away anything. So when the transaction again shows up in the case of these guys, and for the first time here, in the form of a block, each of these guys, without communicating directly with one another, steps through each transaction. What do? First transaction, they pull out the read set. They peep into their version of the database, which is all fully replicated, mind you, and see whether, for the items that were originally read, whether they are still in the same state. Let's not get into details of exactly what that means, but there's a state variable that says in a succinct way what the state is. If it is, that's like optimistic concurrency control, the validation succeeded. Then all that each of these guys does is plonks out this write set and dumps it into the database. That transaction has succeeded. It's possible that as a result of that update being done, set of updates being done, the version numbers get bumped up for all those things, which might then screw up the subsequent transaction which happened to read one or more of those same items that this first guy had modified. And this is why there can be failures of the validation, right? It could also be because between the time of the simulation and the time this third step happened, other blocks could have gone through the same sort of thing. So data could have changed because of that also. In any case, the net of this whole thing is that certain transactions will succeed, other transactions will fail, and that is marked as metadata associated with the block. Which transactions committed, which didn't commit. And that's stored persistently in the blockchain, okay? And that's basically it. So to make matters awfully simple, if there's only one piece of data and all the parallelly submitted transactions are just adding 1 to the existing value of that one piece of data, guess what will happen? Let's say 10 such transactions got submitted in parallel and they got put into a single block. First guy will succeed, the 9 will be blown away, which is pretty pathetic, because if you compare that with what I said before about database replication, if you dump all the transactions at one primary node, even if they are all going after the same piece of data and hence there's no parallelism, at least one at a time they'll all execute and succeed, and then they'll all get replicated. But because of this way in which it's being done, where in parallel you are submitting these different transactions to the different guys, and they are all extracting whatever they read and capturing that, and ultimately that's playing a role in who gets to succeed and who gets to fail, that rate can be awfully, I'm looking at my friend, this is one of the major reasons why this rate can be stinko compared to what a more traditional way of doing things will be. On top of it, today at least, they don't allow in any of those nodes which are participating in both simulation and validation, both simulation and validation to go on in parallel. So there's a high-level lock that's being acquired. Multiple simulations could go on in a given node because it's all doing only reads. But at any given time, only one block validation can be going on, and that will be excluding any simulation from going on because the block validation is going to be making changes to the database. This is also partly because of the restriction I said before that comes from using these silly database systems which don't have full-blown transaction concept and all that, and traditional locking that goes across different API calls and such. So there's a whole bunch of mishmash of things that are going on that cause problems here. Okay, so this is all just more details that I'll let you go figure out. So one of the important lessons from looking at this gory level of detail is that because that layer of the fabric in between the chain code and the database is doing this policing of the API calls during simulation, if you stretch this idea and you now start supporting SQL, guess what? This in-between layer would have to become like a full-blown DBMS, because you can now have set-oriented update calls, IUD calls, insert, update, delete, where you have to carve out the select part of those statements, and those should still be sent to the DBMS. It's only the actual update, insert, delete that will be trapped by the layer above. So now you have to do fancy SQL-ish, not just syntax, but even semantics and all that, and gets really crazy if you now have stored procedures and referential integrity, this, that. This layer on top cannot do all that without having access to the schema information, and I have to really get into gory details of database stuff that maybe Srini will be interested, but most of you probably won't be interested. That will make it really hairy to deal with. So that's part of the problem that comes. And also, if you pose a query, modify all San Jose guys to Almaden during simulation, and you got back some result for who are all the San Jose guys, between that simulation time and the validation time, new San Jose guys could have shown up. So you cannot just make sure whatever you retrieved before is still in the same state. You have to really re-execute the query to know whether new phantoms have shown up. This is, again, those of you who know enough about phantom problem and repeatable read and all that will be able to relate to it, but if you're not that much geeky about database stuff, you won't necessarily follow what I'm saying. But in any case, the point is, anytime you define an API for database and you say pluggable, blah, 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 the usual nonsense happens, right? Do you take the least common denominator across different kinds of database systems and make that common API? In which case, you're going to use a relational system like a key value store, which is the dumbest thing to do, right? And then if you want to do analytics and all that, this is worse than pre-relational, right? Pre-relational VSAM and IMS had primary key followed by a bunch of fields that you could refer to. Whereas this dumb key value store, you have a primary key and then a bag of bits. It's left up to the application to figure out what the semantics and the real structure of that bag of bits is, which is worse than even 50 years ago, 60 years ago, pre-relational kinds of things like VSAM and IMS. So there is yet another consortium called the R3 Corda, which has a whole bunch of players again. They have their own special features for JVM to guarantee deterministic behavior. It turns out they discovered between one release of the JVM and another release for the same code, there is no guarantee of exact same behavior, which is like mind-bogglingly crazy. I don't know, some cache line size or something is introducing some non-deterministic behavior. But they do support using a relational DBMS, and they even allow the ledger data to be SQL queryable and even joinable with private data. I don't know enough of the details of this one to know, as I talked about the fabric, whether this introduces its own complications and goofy behavior. But at least at the high level, this is what they are stating. And they have their own language, which is simpler than Scala. They call it Kotlin. They're also saying that in addition to different parties agreeing to the execution of a transaction, there are additional constraints that might be placed on these output states that are produced by the transaction, so-called contract statements, which you can think of like referential constraints and such in traditional databases. And those also have to be satisfied before a transaction will be deemed to be okay to proceed with. Okay? So it's not just merely the voting by the different participants, meaning the peer nodes. This is more details, but they're just showing that there is off-ledger data, there's on-ledger data, and things like that. And they are supporting relational and even combining stuff with other kinds of databases. With all this, you should keep in mind, it's not just doing the blockchain transaction that's the mainline business, right? A node may be accepting an order from somebody in this sort of consensual way, but once it's accepted, in order to fulfill the order, it might have to interact with its age-old SAP, whatever kind of systems, right? So that is now taking data out of the blockchain and doing something with it, and then it'll put back a thing saying, okay, I've now built this product, it's now being shipped, and now the whole blockchain way of doing business comes in. So this integrating the data of the blockchain with any other kinds of legacy backend systems is still an important thing to think about. And that's where having access to SQL to do these sorts of things and having a relational database as the state database will be a lot easier than monkeying around with all these non-relational things. Yeah, you can talk about Spark and this and that. We are all talking about such things too, using Spark for. But the amount of data is so Mickey Mouse now. Trying to call this big data is a misnomer at this stage because there's not a whole lot of data there that these relational systems can't handle in the traditional way. So over here, for example, they talk about like in a P-tree net, this is where the workflow management and business process stuff that I referred to comes into play. Stuff gets consumed and new stuff gets produced, which is the way P-tree nets work. Tokens float around the network, right? Those sorts of ideas are also talked about here, consumed historical states and the unconsumed state and new states being produced based on consumption of previous states and things like that. So these guys have more higher level notions than what the fabric right now has with respect to the different modeling constructs and the programming model that they support. They also have, for instance, this notion, right, where you are doing this transition, you are trying to do this transition from cache 0 to cache 1 state and also bond 1 to bond 2. In addition to the different players agreeing to this kind of transition, these two states have to satisfy the corresponding contracts. That's the reference I made earlier too. Something like referential integrity and things like that. They are even, to go even one step further, keeping track of transactions and which transaction triggered which transaction. So they are doing this tracking also in a way where you cannot fabricate things because there are these hashes being used to keep track of this transactional, what is the word I'm looking for? What do we call it? Keeping track of provenance. The provenance of transactions, which triggered which, and so on. Okay, BigchainDB, I talked about it already, the Berlin startup, which started out working with Rethink DB, just a single cluster, and now it's also trying to do stuff with MongoDB. They have this notion that all data is stored as JSON documents in one of these two kinds of databases. They are talking about all this interplanetary file system and things like that. So there's a bunch of stuff that's going on. I don't know exactly what the current status is and how production ready this is. There are more details of it. I'll skip these things. But they also have this notion of assets and conditions on inputs and outputs and state transitions having to fulfill certain things. Plus, they have this idea of a signature condition, asset given to entity controlling a corresponding private key. So there are key related things also that determine who gets to do what and to what piece of data and things like that. These are more higher level, I would say, than the sorts of things that today the Fabric and some of the other systems are supporting. They are comparing themselves to various things. So the Sawtooth project, which is the other project that I said was part of the Hyperledger Consortium, was initiated, and it's still, as far as I know, in the incubation stage by Intel. And they are, instead of using proof of work, they are trying to use something called proof of elapsed time, POET, which is considered more efficient than proof of work. They are trying to make this work in the Intel SGX environment, which is the secure execution environment. But currently the problem is that Intel only supports small amount of memory to be used for this purpose, whereas the IBM mainframe one I referred to before, it has gobs of memory available, and so you can run the whole container that executes the peer logic, as well as the container that executes the smart contracts, all within that secure execution environment where even the operators and such cannot look at anything, cannot tamper with anything, data or the code. So they are, at least as of a few months ago, they had said it was not secure enough for it to make it to the real world. Ripple has been in existence for a long time in the context of foreign exchange transactions to make money transfers across country borders more efficient. They have now recast it to be like a blockchain. And this is the project that I said recently got admitted into the literally like in the last few days into the Hyperledger Consortium as the Quilt project, the Java version of this, what they call the Interledger protocol. They are trying to promote the transactions that span ledgers. Okay? As of now, I haven't talked about such things being permitted in the Fabric. It turns out if you have two channels and from one channel's smart contract you want to access another channel's data, today I believe read-only access is allowed, but you cannot in one transaction modify the data that belongs to two channels. One thing I forgot to tell you is that in the Fabric today, the data that's managed by a given smart contract is disjoint from the data that's managed by a different smart contract, even within the same channel. Disjoint meaning it's not stored separately or anything, it's just different pieces of data. So if one smart contract wants access to the data this is like abstract data types, information hiding. If one smart contract wants access to the data that's in the domain of another smart contract, it has to invoke a function there and get the data, or to modify the data over there. But that works only within a channel. But across channels, it's, I believe at this point, only read-only access. Whereas these guys, before all this fancy blockchain stuff came along, they were allowing different bank institutions to do transactions that span ledgers of these different banks or consortia of banks and still guarantee atomicity and all that. So they developed this thing called the interledger protocol. I won't get into the details of that, but only to point out that you would think with that three-stage transaction execution that I showed, where the client is talking to multiple peers and the ordering service is talking to all the peers in the channel, all that people have said means all these peer nodes have to be in the public cloud, because all these silly people are talking to, you know, different organizations' machines or systems. And so people thought, oh, this won't work behind the firewall. But it turns out the Ripple guys do make things work behind the firewall. So this is the back-end firewall, this is the front-end firewall, and then there's a HTTP reverse proxy, and the Ripple code is running here. And they even allow you to use, I had said it in the previous slide, some relational systems like PostgreSQL and Microsoft SQL Server. They give you the schema that you have to now use to declare the data in your backend database system. And so they've somehow made it all work behind the firewall and things like that. But their thing is not as you know, involved as what I showed you with the three-stage transaction execution. Here it's more like point-to-point kind of messaging that's going on, which is the traditional way in which EDI and such worked, right? Where companies will do point-to-point communication of orders and purchase orders and invoices and things like that. But the whole information was distributed, and there wasn't a single place where you could go to get at everything. So, which is what the, you know, the blockchain way of doing business is providing. So I'm just repeating the slide I showed you before, just to say that, as you would have seen already with these different examples I gave, there are different choices that people have made with respect to, for instance, the consensus approach chosen or the kind of database system used, whether it supports transactions or not, and whether all the data is kept in the chain or some of the data is kept off chain based on maybe the size of the data and things like that, which is no different from, even in relational database systems, we had this notion of long field or blobs, where we treated the blob data differently by doing direct access to the file system to manipulate the blobs versus the relational mainstream kind of fields being managed directly by the DBMS and going through buffer pool and all these kinds of things. So just to sort of give you a very high-level view of what my current project is trying to do, I'm trying to replace what the smart contract allowed you to do in the Hyperledger Fabric version 1, which was all this put and get delete calls, with full-blown SQL, select, update, insert, delete, and such. But remember the caveats I gave you. If you follow the current approach, the layer that's sitting in between the smart contract and the database would have to become a super-duper relational engine, and I don't want to do that. So which means I'm doing something more you know, involved and intricate and all that, and we'll reserve the discussion of that to a different day so that you all can go home and do whatever. So just a couple of slides of futuristic topics. I've already pointed out some of the problems with the chain code portability. If you take advantage of the underlying database system's full features, you cannot easily port that chain code as is to some other underlying database system. This is no different from, even with all the SQL standards, we all know that between Oracle and DB2, there are some non-standard features, including the stored procedure language, right? So if you want to do that porting, life gets complicated. At least if you stick to the SQL standard, then you will have an easier time. Of course, IBM went and did an Oracle compatibility version of DB2 to make portability of such things easier, but it gets even more involved if you are doing, you know, porting across different NoSQL systems, since there's no standard there, or between SQL and non-NoSQL systems. And doing analytics is an important thing in this day and age where we talk about HTAP, hybrid transactional and analytic processing, which was the project I had been working on until I got hooked to this last year, which IBM announced recently as the IBM DB2 event store, which we have written papers on called Wildfire, which is allowing both OLTP and OLAP to be done against a single copy of the data, a la HANA and such, MemSQL. We would prefer to do that because if you have to extract the data out of the blockchain and dump it into like a warehouse to do your analytics, guess what? All sorts of headaches come with it. It's not up to date. More importantly, I'm going to make sure that the same rules of access that you enforce when the data is in the blockchain will also get enforced when the data is off in a separate place. So lots of tricky things come up with that one. And so if somebody loses a privilege on the blockchain side, how soon will that get reflected on this other cache data that's sitting in the warehouse and so on? And many app design issues that I already pointed out about, what is the right level of endorsement specifications to think about in a certain context and such things. How many nodes to have. You have to worry about even the peer nodes failing, right? So there are some companies where they want to have multiple peer nodes, where there is a primary peer node which may be on the public cloud. Then there are other peer nodes which are behind the firewall. And so they want to do then workload balancing, that sort of thing. So there are many, many such things that also come up from the context when you think about failures and fault tolerance and such things within an organization's peer node. And cross-channel transactions I already talked about, and also the bigger issue of, since you have now these different kinds of blockchain systems, how do you do interoperability across blockchain systems? There is something called sidechain that somebody proposed. There's a UK company, I think. But if you are the research kind of person, you have lots of possibilities for PhD theses, master's theses, and research proposals to get money out of NSF, DARPA, whoever. Last slide. So I do post lots of stuff all the time on various social media accounts of mine. I use Facebook not just for posting pictures of social events. I actually use it heavily for professional things also. I actually get a lot more hits on Facebook than on LinkedIn and Twitter and such. So, and those in China who have interest in Chinese ways of doing business, I'm even on WeChat, although I don't use it as much. Thank you very much. Any questions? Oh.